Hi, I'm Pagra12 and today we play with custom particles and we solve collisions. And we build this patch with which we can create those circle packing layouts with any input photo or video. So let's build this from scratch. I leave this aside and yeah, let's start. We need a constant chop. So let's go with resolution X, and yeah, let's go with 1280. The ratio, I will go with 21:9, and also the map, and we go with 8. This meaning the size for the texture in which we have the particles, and so we'll have 64 particles. Okay, and what else? The radius. Okay, let's go with 1 divided by 64. Okay, now I would like to have a folder. For that I insert a null here, collapse selected. If I click outside, and now we have this folder. I name this data. Okay, let's go inside, and here select the resolution X and the ratio, and we rename into resolution Y. Okay, now we use a mat and we go for divide into combined channels, and now we have merge. Okay, what else? I would like to have here keyboard in to reset a feedback. So I rename this into reset. Okay. Now let's go outside and let's build 6 bases. So I'll have one basis where here is the starting position. I often name these either particles or count. Let's go for count. Okay, and yeah, here inside, or yeah, maybe should we copy paste this? Okay, here we'll have vectors. Okay, another one would be the engine. Okay, and I also have something for the renders or buffers. Let's name this render. Okay, and another one for compute, and this is like compute shaders, or something in which you go for some heavy computation. Okay, let's start with this. Okay, I open this as a window. Let's go inside. Now for the count we go with 2 noises tops. Okay, so let's drag the map here. This is 32 mono. We go for nearest pixels, and I'll go with random GPU. I color this red and copy paste. I change the seed to 2 and copy this to green. Now if we reorder, okay, let's take input 2 for the green, and this should be 32 RG. Okay, now an alt, and we almost done here, but our pixels now, they are spread into 0, 1 area. So let's solve for the ratio with the mat, and we color this green and also mask the red channel. So now we divide this with the ratio 1 divided by, and so yeah, right now our points are perfect distributed in our area. Okay, okay, what else? Let's go here And we'll start for the vectors with only a constant and all the values 0. So will not have any effect. But so this is 32RG and we have 0 here. Okay, let's go with an out. Okay. Now this engine, it's working like each frame it's adding a vector direction to the position. So we need a feedback. Okay, so let's have two in operators. Okay, and we connect those two, and here we need to add them like this, and we have an out also. Okay, now I would like to insert the feedback here. I color this feedback black. Let's drag the reset for the pulse and the reset, and we grab this add. And now let's set everything to nearest pixels, and we done in the engine. Okay, what else? Let's go for the render, but before let me split the screen. Okay, and yeah, let's go in render. Here we need a geometry because we will use instances, okay, for circles. So we have a camera, a render, okay, and here an out. Okay, now those two goes black. Inside the geo, let's delete this torus, we don't need it. Let's go for the circle SOP. Okay, and we drag the radius here, and also 32 divisions. Let's turn on those flags, and now let's go for the instances. Okay, and now I drag from the engine out where I have my points moving. Let's drag this here and go for R and G. Okay, now we need a constant material to go in the render, and in the camera we go with orthographic bottom left and 1. And also here let's set the render on this resolution. Okay, and the output would be 32 RGBA. Okay, maybe we don't need anti-alias. Okay, and we good. And now yeah, let's have a look on this folder. So I split this in two. I'll drag this here. We have a top. Okay, okay, let me arrange the layout like this. Now, as you see, for the couple of the circles, we have some overlappings. And how we solve that? So the overlappings is when the circles goes like this. And that means the distance between them becomes smaller than 2 times the radius. And we need to find the distance, and the radius we already know. So how we do that? Okay, let's go here in compute, and with a select like this, let's grab the engine out. Okay, this is where we have the points, and in order to find the distance, we need to repack this texture into some different arrangement. Right now we have 64 pixels. Let's have a texture 64 pixel long by 1, and that would help us in solving for distances. So for that, let's use point repack from the palette. Okay, and we repack into 8 power of 2, so like this. Okay. And from here, it's something we've done in plexus tutorials. So finding the distance from each particles to all the others. Okay, so we need a fit here, and let's copy this expression map power of 2 and use it in the fit with nearest pixels. Okay, and we go for fill. Great. Now here we use a flip. We go for bottom left, and now we have subtract. Okay. And here we have a mat with length, mask the alpha. Let's check. It's RG. The blue doesn't matter. And here it's 32 mono. Okay. Now this is the distance. Okay. Select all. Maybe nearest pixels to see it better. Okay, so this is the distance, and it's arranged like this. Imagine you have each particles here in the bottom row, and for each particles the pixels above on that column, it's the distance to all the others particles. Okay, and we want to check where is the case for having the distance smaller than 2 times the radius. So for that, we use a mat. Okay, let's put it here. And we subtract the radius multiplied by 2. So let's go with minus 2 multiply. Oh, okay, minus 2 multiply with the radius. Okay. And I would like to find out the actual pixel where this condition is true. So let's go with mat. I will use another mat for this. So let's go with mat and ceiling. Okay. Now don't mind the black oblique line, diagonal line, because we can solve that with a rectangle. So if we take a rectangle and we go with set resolution only, so we connect this output to this input, and now we have the same resolution. Let's go here in the size, we go for pixels, and the length would be 64 multiplied with 2. I believe this would be enough length to have the entire line in the diagonal. I will show you right now. 45, and yeah, you see something very, it's not white, and it's because of this anti-alias. Okay, now, okay. In this mat, I want to be sure that values are either 0 or 1. I can always check with analyze and chop and yeah, be more precise. But yeah, I already know that I should limit this with clamp into 0, 1. Okay, now this texture is either 0 or 1. The one above with the line is 0, 1. If I add them like this, okay, now where I have black dots is where I have the touchings. So for that I would like to use a level to inverse them, and now it's much better. So for the white pixel I have an overlap that I need to solve. Okay, so how we solve that? With half of the overlay, half of that, and we push in the opposite direction the particles. Half of that it's here if we use a mat with 1 divided by 2. Okay, and now if we multiply this level with this, we have for every white pixels, we have the value, meaning the half of the overlap, okay? And now we need to multiply this with the direction, because this is mono, okay? The direction is it's here in the subtract, and we need to normalize this. So let's have a null, collapse selected. Let's go inside, name this normalize. Okay, I'll make it black. And let's go inside. We only need two operators. One is composite, for which we go with transform input 1, and here divide. And another one is mat, not mate. So mat. And this takes length, mask the alpha, and yeah, go with 32 mono, and now we connect like this. And yeah, we have the values normalized. That meaning that the length of all the vectors is 1, and visually it's like this. So all the points are equally distant from the center with length 1. Okay. Now I would like to change this null for an out. Okay. Okay. And now if I multiply those two, I have exactly what I need. So each columns contains the forces needed to solve the collision. So, but there can be many of them. There can be 0 for some particles which are not even close to the one in discussion. And we can go with average. Let's go with analyze and average for the columns. Okay, and yeah, we have some values here, very small, hard to see. But this is all not so correct, as we might have in that column some 0 values for the particles that are not in contact. Okay, and with average we ruin the precision. Okay, so instead of average we go with sum. Okay. And now we use the same analyze with sum here in this level. Okay. And now we use composite. And go with transform input 1 and divide. And this should be RG. And let's go with an out. But you see the texture is long, so we need to make it back into the map resolution. So yeah, like this. And now that means in this texture we have the direction for circles to solve the collision. Let's see if it's working. Okay, and let's go in vectors, and we use another feedback. Okay, and let's color this. We drag the reset for the pulse and reset, and here we take compute out. Okay. And yeah, what if we connect now? You see, we have some jiggling pairs of circles, and this is because in the compute, in the subtract, yeah, we need to switch those two inputs. Okay, now if I press 1, you see they already solved the collision. Now let's go with higher numbers. So if we go with 32 for the map, That means we have 1024 circles. They might not have enough place to stay all of them in this area. Let's see. So yeah, they go outside. What I would like to do is to build a stroke. So let's go here. Now we can color each circle with some value that would be easier for us to use an edge and then make some lines. In that case, when using edge top, you will get a line double in size. So you can't get a line 1 pixel thick. For that, I guess we go with another geo, okay? And this one is black, okay? And it only takes it's wireframe, okay? Now you see, yeah, we have some black edge, but what I would like to do is use a render pass, okay? And yeah, now if I go for the deep peel, now I have only the lines, and I can over this anytime after, and yeah. So now if you take a look in geometry, you see the circles went outside 0, 1 or our ratio, and that is because they are way too big and don't have enough place, okay? And yeah, let's test this for smaller circles like this, okay? So you see very fast with not a single frame lost, we have a collision for. What if we test a way higher number of particles, like 64 for the map? That means we have 4,000 and something. So yeah, the FPS it's dropping a little bit, and that means that, yeah, on a normal GPU, you can run 1,000, 2,000, 3,000 particles with this method. And yeah, once you go higher than 4,000 or 5 or 6, and that means you need a stronger GPU or a different method. Let's say you need a trick for higher number of particles, okay? And yeah, let's see what we do. So I thought this would be the tutorial. We put some colors and then maybe a remap or an image or something, and that's it. But I just turned 46. Yesterday was my birthday, and I was thinking, what if I'll make even nicer this tutorial and show you how can you do different sizes for the circles, because that is I believe it's much nicer, okay? So yeah, let's do that, and then we color, and yeah, so let's build the 6th base, okay? And we call it scale, okay? Let's have this black. Go inside and use a noise. Now for this noise, we go with this map. By the way, I should change the map. Let's go for 35. 35 would be the maximum number for the for some of you using non-commercial license. The moment you rearrange the texture like this here, you'll end up very close to the 1280 limitation. So 35 is the maximum, but yeah, it depends on the sizes and what you do with the particles. sometimes 1000 it's good enough amount for doing some nice visuals. Okay, so yeah, let's drag the map. It's already there, and we have an out, and this is like I want to have one mostly like this, but some variation, and I'll go with 1 divided by 3 for those variations. And also if you go higher, like 2 divided by 3, sometimes the smallest values go below 0, so it's always good to have here a math with positive. Okay, so yeah, we done here. And yeah, how we use those scaling factors. Okay, so let's go in compute. Okay, and use a select, and let's go get the scale. Okay, like this. And here we have the scale for each particles, but sometimes when we need to solve the collision, we need to subtract from the distance the two radiuses. Okay, and here is when we have different results. Okay, now what I believe it's a good idea is to copy the example above, like here. Okay, so we copy those like this. Okay, and here instead of sub, let's use add. Okay, now remember, this is not the radius, this is a scaling. The values are mostly 1. Okay, so way too big. Now I build this in order for you to see better, but either here at the beginning or right after, we need to multiply this with the radius. Okay, and yeah, this is RGB. Just a second, because in this noise for the scale, let's set 32 mono. Okay, now we good. And here in this texture we have those two radiuses, radius 1 plus radius 2, or and yeah, let's use it here. So if we subtract the radiuses like this, now we go subtract like this, and yeah, let's change here. Okay, now we can't see too good, because now, yeah, we need to adapt to update the sizes in the render. Okay, so go in the render, in the geo, both geos. Okay, and now for the scale we drag this out, and we go RRXY. So now we have different sizes. Okay, let's try. Yeah, very nice and smooth, and yeah, it's much nicer when the radiuses are different. Okay, now how we color this? Let's color this. So let's have the colors where they start first. Okay, so we go in render. Okay, and here we use colors from count out. Okay, so instance to those colors R, G, and B. Okay, now you can't see too well with these UV colors, but what if we take an image and yeah, spread the image on those circles? Let's do that. Let's do it here. So let's select the count, and we'll see. And now let's have with the movie file in. So movie file in. Let's get some nice photo. I don't know. It's this one. And I want to remap, okay? Because I'll do like this. So remap. First, now obviously it is a square because I make it so. But what if you have an image which is not square? So in this case, we use a fit here, okay? And yeah, I don't know. Let's use this resolution. Even if my photo here, oh, let's find another photo. I don't know. Let's okay. We don't have photos. Oh, right one. Okay. Now, so we have this photo. Let's fit here with fill outside, and now we remap, and we use the UV image, so 35 on 35. Okay, this is 32. I need this to be RGB, so RGB like this. Let's make sure this fit is 32 RGB. Okay, and now something that you need to remember always when you remap in this texture with which you remap, you need to be in between 0 1, and that means I need to use a mod and solve for the ratio on the y-axis. So this is green. I'll mask the red, okay, and we go with ratio here in multiply. Now we good. What if I color this? So let's drag this into colors. Okay. Great, because we need to solve for the ratio, right? And let's see how what I need to do. Okay, like this. I believe let's go with this resolution instead. Yes. So there is the problem. My image is not landscape. Okay, it's but yeah. Let's go with this, because what I will do is close this one, and yeah, let's go with top view here. And now I have this, and let's go now with ratio 1. Okay. Now it's much better, okay? And yeah, 35 being the maximum, you can increase the radius. Let me put a RGB key here, okay? You can increase the radius for them to 64 maybe, okay? And if you wait a couple of seconds, you'll have this very clean packing layout. But we still need to solve for something like kinetic energy. And what that means, if I'm a particle, I have a force, a big one, I go into that direction. In the next frame, some of my old direction and force, it's still there, okay? Even though I might collide with something else. Then, so we need another feedback, and we grab a little bit of the force we have, and we walk it into feedback. For that, let's go here and copy constant feedback once again. And yeah, let's make like this. So this is add with this. I need a multiplication factor with the math. I can go here and say 0.9265, let's say. And yeah, this feedback takes this add now. This one takes the out, and let's go with this. And now you see they are jiggling a little bit more, but more natural motion, okay? And yeah, they solve packing much faster. Have in mind the value. If you change the value here too high, you might break it, okay? So in this case, they go outside. They have no limitation, okay? We can build such a limitation. Let me lower this down like this. And yeah, let me increase here maybe 55, okay? And I want to go with the radius way low, like this. Okay, much better. Now, one thing that I would like to show you is how come we build this in order to have the nice image at the end. When the particles settle, I would like to see the some nice photo, okay? And that means instead of, let's go here, okay? And instead of having the count out, let's go with engine. Like this, okay? And now you see, it doesn't matter where the particles move, they always get the color from the photo, okay? And if I reset, you see, now it's hard to see. I will show you another trick. What if the particles won't start already spread in the area? Instead, they start from the center, okay? Let's go here, and yeah, right after this matte, let's have a blur. Okay, let's see now. Yeah, they start from the middle now, and you see each particles adapt update the color while walking the texture. Okay, now if we, and here you can go with repeat. Yeah, you can't see the difference right now, but it makes more round starting position. Okay, what else? If I want to have the final image only being revealed in the end, I can go in this render here, and I will lock this texture. Okay, watch what happened when I reset. Okay, now they don't change the color anymore. They have a good color, but you'll see the final piece, final puzzle at the end. And yeah, this is how you control by playing with how much the overlap is being solved. Okay, right now we have half of the overlap. Let's go with 1. The result will be much more brutal. Okay, so the jiggling is much more pronounced. Look what happened. You see, because each overlap is solved by pushing back, and after that, one particle can come over the other one and being pushed back, and that's why this jiggling is happen. But you can go half or even smaller, and so you'll get way much smoother motion. Okay, if you want to increase the speed, let's say, you can multiply here in this vector. You can multiply the force, or you can change this factor of for kinetic energy trick. Okay, going I don't know, 99. You see, what else you can do? But with this high number here, will be a total mess. Okay, let's see. What if I want to limit those into 0, 1? Okay, now you can go here in engine, and you go with null. Okay, click outside, collapse selected, and this is limit. Okay, and yeah, let me show you a couple of ways you can limit. Okay, so I use limit for the red, because we want to make something that will function if we go in some crazy ratio. Okay, so we limit first for the red, and with zigzag, let's go with zigzag into 0, 1, and for the green we go 0 and 1 divided by the ratio. Okay, and in this one I'll mask the green, in this one I'll mask the red, and we good. Okay, now let's see if we have enough force to see them. Not quite. Let me increase here this number. I'll go with 965. Okay. Now you see they don't go outside. Okay, there's no other force acting once they hit the border, you know, so they settle once they hit the edge. Okay, yeah, this was my tutorial. You can build some crazy stuff using this method of computing distance by rearrange textures, and yeah, I really hope you like this. Thank you so much for watching. You can support me on Patreon. You'll get access to a bunch of other tutorials, some of them easier than this, some other much more difficult or complex, and yeah, you'll help me going on with this research for computation using only textures. I would like to thanks to all my patrons, and yeah, see you in the next one. Bye.